I'm going to go ahead and get started since the keynote ran over a little bit. So welcome. Welcome to learning about algorithms and CS integration. My name is Molly Plyler. I'm the Director of STEM and CS with the Jackson-Madison County School District. The room moderator for today is Dr. Teresa McSweeney. She's graciously playing Vanna for us. But so excited you are here. I have lived in this computer science world for about 8 years now. I started out as a classroom teacher 20 years ago in high school biology and AP biology. I'm married to a software developer, so he was incredibly happy when I came into computer science because now I understand what he does. You know the Charlie Brown teacher voice, the adult voice, that rah, 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 rah? Yeah, when my husband was going through grad school, I remember him coming home and being like, hey, Molly, today I learned about, and all I heard was rah, 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 rah. So hopefully by the end of this session, if you are new to CS, you'll have some basic vocabulary and some ideas of how to bring this back to your classroom. Now, for raising your hand, so I know who's in the audience, if you are brand new to computer science, coding, any of that stuff, raise your hand. Okay, awesome. So we have some new people. If you teach elementary, raise your hand. Awesome. If you're in middle school, raise your hand. Awesome. If you do high school, raise your hand. Okay, good deal. So we're going to have this session sort of hit on all of those grade bands, but we're really going to dig into the idea of computational thinking and the thought process that will help our students become strong in computer science. Now, one of the things that you'll see and that I love to do in my classroom is the language matters. The words that we use matter. So you'll see that even on our agenda today, I call it our session algorithm. And an algorithm is simply a list of steps. So if I think about this, I think about a former high school student that I worked with. He lived in rural Tennessee. His name was Colton. Incredibly smart kid. Now again, he lived out in the middle of nowhere. So if he wanted to have access to the internet, he literally went to the local McDonald's to get online, okay? Well, a little bit later, he's in this coding class. He's doing this awesome job. He gets this amazing scholarship to Vanderbilt. He's going to major in computer science and mathematics. I'm like, man, Colton, you're awesome. This is so exciting. And I said, okay, if I record a video clip of you talking, can you talk a little bit about what has this experience been like for you in computer science? And he looks at me and he goes, Miss Plyler, I thought computer programmers were these magical people who only lived in California. And that was my aha moment. That was my moment of realizing the words we use matter. So many individuals are intimidated by computer science because they don't speak the language. So that's the reason when our students say the word algorithm. So even in my classroom, when I was in the classroom, you would see, instead of saying agenda or daily schedule, I use the word algorithm. So in our session today, we're going to talk about the shared vocabulary related to algorithms, computational thinking, and computer science. We're going to talk a little bit about perceptions and beliefs. We're going to talk about a research model called the 3C model. And at the end, we'll have an ideation activity where hopefully you are inspired and you get some ideas from our colleagues in the room of how can I integrate CS into any subject that you're currently teaching. Now, when children say algorithm, we give them the words they need to build the foundation in computer science so everyone speaks the same language. So just like Colton was a smart kid. He knew how to do this. but he didn't speak the language of computer science. So when he first entered this world and he tried to teach him some stuff online, to him, I might as well have given him like Mandarin Chinese, right? Because none of it made any sense because it was a language he didn't understand. Now, simply put, the definition by the Department of Education of an algorithm is a step-by-step process to complete a task. Guess what? Elementary teachers especially, you guys are experts at algorithms. You use algorithms all the time. Raise your hand if your classroom has a morning routine. Anyway, that's an algorithm, right? It's a step-by-step process the students need to do. Let's think about different subject areas. In ELA, anybody have an algorithm for the writing process? How to write an essay? Yeah. In math class, anybody talk about our order of operations? Yeah. Let's think about a history or social studies class. Has anyone ever asked your students to list out events that lead to some historical events, like a timeline, right? That's an algorithm. So we use algorithms in every academic area, even the PE teacher. Do we have a PE teacher in here by chance? PE teachers do this all the time. If you go to PE class and you listen to the PE teacher introduce the activity, what's the first thing that they tend to tell the children? Here are the rules of the step-by-step instructions for how to play the game. So even in PE, our children are given algorithms. But the challenge becomes, do we use the word algorithm? No. So our kids never connect the dots that they're doing the same thing in all of our classes because we're all using different words. Now, to explore this a little bit further, let's think about computational thinking. When Tennessee launched the Reach Them All program, by the way, do we have any Reach Them All delegates or ambassadors in here? Oh, yay! So if you're not familiar with this program, you can go to TSIN's website and read about it. But your local district is getting ready to push out computer science training to everyone. The definition that Department of Ed chose to have for computational thinking is that they were going to focus on algorithms, pattern recognition, decomposition, and abstraction. Now, if we look at ISTE has a really neat comment here too, because their comment is ultimately, it's not about the technology at all. In fact, it's about changing the way learning and teaching takes place to make it more meaningful and impactful for educators and learners around the globe. It's about turning the what ifs into what is. So as we go through this session and we think about what are concrete activities, what are concrete lesson plans that you guys could leave today, go into the classroom tomorrow and do, I really want you to lean into the idea of this thought process. It's not about the gadgets. Let me repeat that because that's important. It's not about the gadgets. Anybody have a classroom set of something that somebody bought for you back in the day and it doesn't work anymore? Yeah. So the kid can learn the gadget, or this is even more disheartening. Anybody ever have the gadgets in your room and the kids can tell you how to use the gadget, but then you follow up with the question of, why did you do that? Or can you explain the process? And they say, I just pushed this button. Yeah, right? Because computer science is not about the technology. It is not about the gadgets. It's about the computational thought process. Now, when we think about the definition for computer science, we think about how computer science empowers us and helps us solve world problems. In addition, we see this concept of algorithms come up again in the K-12 computer science framework. because that official definition of computer science, excuse me, includes the principles, software, hardware, application, and impacts that computers have on algorithmic processes. Now, so we're going to start out with an activity. You will want to go somewhere where you see some paper, and if you don't have a marker, feel free to use a pen. But here's what I want to do, and I'm going to set a timer. I want you to draw what you think a computer science looks like. Okay? So get with some people, find a piece of paper, draw your idea of a computer science. You get 3 minutes, go. Markers down. I want you to take a minute, hold up your sign, hold up your drawing of your computer scientist, and everyone kind of look around the room. So first off, some of you guys get extra credit because your artistic skills are pretty amazing for a 2-minute drawing, right? Okay, so I see a lot of stick figures. You're my kind of people if you stick figured it. I see that we have representation for all. Oh, can you please come share your drawing? It's like I planted her in the audience, you guys. Oh, man. Okay, share.
Make sure everybody can see themselves.
This is a mirror. You're all computer scientists. You're all computer scientists. So thank you. Give her a hand for coming up. Now, here's what I love about your drawings. If we actually look at how this activity tends to go with children, the pictures are very different. In fact, there was a study done in 2017, the Hansen study, and it showed that pre-students having any sort of computer science instruction, the picture of the computer science that they drew tended to be men around 25 years old. They worked alone. There were computers and doing just whatever task, right? But then after instruction, we saw that the pictures changed. And you guys are a great example of that. Because in your pictures, we had representation male and female, we had people doing things, and then we had the wonderful picture of the mirror. This is you. Now, why do I bring this up? Did anyone ever, like when you first heard that we had the new CS law, and especially elementary folks, that we were going to be integrating CS, did anyone have that thought, isn't that what that computer teacher is supposed to be teaching? Right. Well, here's the part of this that's so incredibly powerful. When we give students CS opportunities, when we give them exposure to how to write code, this is just like when we give them the power of learning to read or write. Once they have those foundational skills, they can apply their knowledge any way they want to apply it. So sometimes, before we as educators can properly teach students about computer science, we need to think about our own beliefs and perceptions. Do I believe that computer science belongs in my classroom? Do I believe that every child in my room is capable of this? Do I believe that there's a place in the tech sector for everyone? So as we move forward, just kind of keep that rolling around in the back of your mind. Now, there was another study done in 2020 by Josias et al., and I love this model. I'm guessing, because we have some Reach Them All ambassadors and delegates in the room, do we also have any school administrators? Raise your hand. Any school leader, teacher leaders, department heads? Okay. At some point, if you haven't done so already, I am guessing that you are going to be asked to go back to your colleagues and present, teach, share this type of information. This is a model that was part of the research study that I love. And part of what makes the 3C model special is that it really helped teachers believe that they were capable of this CS integration. In fact, when teachers used this particular model, you had 90% of the teachers who would agree or strongly agree that they are more likely to incorporate computational thinking into their classroom and design these types of lessons, which have been proven to better engage students. So here's what the model entails. The 3 C's stand for code, connect, create. So again, code, connect, how am I connecting this to other academic content? And create, actually creating some kind of work process. So the first version of this, we're going to do together. Then I'm going to give you time with shoulder partners, table partners, however you want to group, to think through this on your own. So the first thing I want to do is we're going to dissect this using the website hourofcode.com/hello. So again, hourofcode.com/hello. This is part of code.org's CS Connection modules. Give me a little wave if you've ever used CS Connection activities. Oh man, elementary folks especially, this is good, good stuff. So Daniel, if you don't mind clicking on that for me. Now, in computer science world, we know that the phrase "hello world" is a very famous phrase when we talk about, first programs and what was said. And so that's why this activity is named that. This is part of their Hour of Code curriculum. So you can actually complete this in like one class session. So you initially get some options of how you want the sprites or the pictures that the students will program to appear. Now, I'm former biology, so we're going to click on animals. So Daniel, if you don't mind clicking on animals. And I didn't think to ask you in advance. Can you show this video? Awesome. So we're going to watch this video real quick on how to complete the activity, and then we'll do it together.
Hi, my name is Erin, and I'm a software engineer here at code.org. I'm so excited because I got to work on the tutorial that you're about to do. We call it Hello World. Hello World is a famous phrase in computer science, and displaying that phrase is a common first step in learning computer science. Over the next hour, you're going to get started with computer science by programming in Sprite Lab. Sprite Lab is a tool you can use to build imaginative and fun projects. You'll see that your screen is split into 3 main parts. On the left is the play space. This is where your sprites will show up. Sprites are objects on the screen that you can interact with, like a character or item in a story or game. This middle area is the toolbox. New blocks of code will become available in this space as you go through the lesson. The space on the right is the workspace. You can drag blocks out of the toolbox and into the workspace to build your program. The instructions for each level will be up here at the top of the screen. If you want a hint, click on the light bulb. To start off, let's make a sprite. This block lets you give your sprite a costume and a location. Costume is the word we use to describe a sprite's appearance. To change the sprite's location, you can click the pin icon in the location block. And then, click where you want it to go. Now, let's have the sprite introduce itself. To make the sprite say something, use this say block and add it to your program. Make sure that the costume selected in your say block matches the costume in your sprite. When you press run, the sprite will say whatever text you tell it to. Now it's time to get started with Sprite Lab and see where your imagination leads you.
Okay, so we are now going to write some lines of code. So Daniel, if you don't mind clicking that X arrow to close out the video. If you have your device, feel free to follow along. So we want to start with a new block of code. So we're going to click on the red block and we're going to drag it over and connect it to the orange block that says when run. By the way, at this point, I have an algorithm, right? Because a computer program is just made up of algorithms. Now, for our third line of code here, we're going to drag over the blue block that has the bear and it says hello world. And we're going to connect it to our red block. Now, how I teach this is different depending on the age of the student. When I have the itty-bitty elementary kiddos, I would literally say, okay, repeat after me, say algorithm, and all the cute voices say algorithm. By the way, if you're being evaluated, totally do that, because your principal might not know what an algorithm is. So they say algorithm. We literally do this together. Sometimes I have the little students do the hand motions of just dragging so they get in their mind what we're doing. Remember, our youngest learners sometimes have challenges with fine motor skills and using the mouse. Like, help us all if you have to do testing with little kiddos with the mouse, right? Your older students, I would start the conversation more like, okay guys, after you have moved your lines of code, what have we created? I'm looking for an answer like my computer program. If I say, how many steps in your program? They would tell me 3 steps right now for your algorithm. Now, I would also, with my advanced students and potentially high school kids, say, okay, how do you execute this program? Now, that's big words to say, how do we make the things run, right? So if I want to run this, then Daniel, if you don't mind clicking the orange run button for us. We got to wait for the sound. doo-doo-doo-doo, right? That's the victory sound. So if this was your first time coding, give yourself a pat on the back. Congratulations, you just wrote 3 lines of code. Now, let's hop back to the slide deck and talk about how does this connect with computer science integration. So we have just done the first part of the code model. Oh, I'm sorry, Daniel. I had this note totally highlighted and I forgot. Can we hop back to Hello World? Here's where your creativity as teachers will help with integration. There are a lot of times when I look at these things and I'm going, okay, this is great, but unless I'm teaching something about bears, how does this connect to anything? Daniel, if you'll please click this drop-down button for beside of the bear. And then, oh, sorry, click last bubble up at the top where it says I finished. Yes. And then X the video. Okay, now go to sprites. He's doing great. I didn't realize I wouldn't have my device. Sprites, click on sprites. Yep. And then drag over make a new sprite and connect it to win run. And now we can click on the drop down. Now, go to costumes. This is where your teacher creativity makes this activity amazing. Because not only are there additional animals listed, if I click the button, the plus sign that says new costume, looky here. Guess what? Now all of a sudden, if I have a lesson about photosynthesis, I can find plant pictures. If I'm teaching about food chains, here we go. If I'm teaching about a piece of literature and I want the kids to code a scene from a book, here we go. Also, the kids can actually draw their own sprites. So I have had students, especially with social studies, CS integration, that they can't find the image that they want to represent the event or the time period that our project is about. So they will actually draw their own sprites. I give them a piece of paper where they needed to tell me, why did you select the sprites you selected? Tell me any interactions you have. And the kids will give you these beautiful paragraphs of, well, I needed the sprite to move in this way because it represented this particular portion of a historical event. So this is where teacher creativity is your friend. I basically spent 1 hour teaching the students how to code, and now they can integrate it or apply it any way they want. Okay, now back to the slide deck. So when we think about connecting it, again, think about activities that you do right now with your students. Are there any projects that are paper-based projects you do right now? Anybody assign like posters or models? Yeah. What about slide decks? Does anybody have an activity where kids have some kind of presentation and they're doing slides? Yes. So question, instead of a paper poster or a digital slide, could they complete this activity and give you student product that was something that they coded? Yeah, in most cases, they totally could. So when we think of these things, the easiest way to start integration is think of what you currently do. What do you currently do that you could tweak a little bit to make it a coded activity versus a paper activity or versus a slide? Okay, next slide. Now, for those of you who've been through Reach Them All, you have seen this computer science model lesson template. I love this. This is probably my favorite lesson plan template, especially in computer science world, that I have seen. I have some extras that I'll bring around. Also, if you want a digital copy of slides or this, if you go to the speaker section on the app, I included these as attachments, okay? So here's what I want us to do. We're going to take the next couple of moments. I am going to give you 5 minutes, and I want you to talk with people around you and think about, what could I code? How can I connect it to computer science? And what can I create? And the creation is, you probably won't fill out this entire lesson plan template, but go ahead and get some ideas from your mind down on paper. The other thing that I would love is if you go to this bit.ly, slide 2 is actually a place where you can add the Post-it notes on Jamboards of what are your ideas for how you can integrate this, okay? So we're going to give you 5 minutes. If you're not sure what websites to go to, I listed some other coding websites that are great intro websites to start with. You're going to talk with your partners. You're going to discuss how can I integrate it and either write ideas down on the template or add it to the Jamboard. Okay? Okay, go. And this is definitely easier if you talk with friends. So feel free, please talk with friends. Here's a few extras of these. If you guys want them, you're welcome. You're welcome. Can you click? A cool idea to add it to the Jamboard. There's actually 3 different slides there that you can add Post-it notes to. Yes, ma'am, this bit.ly right here. So bit.ly.ws/C/Y B4. Oh. No, not handy. I'm sorry. I did it as links in the slide deck. Were you able to get on?
I can't see that, and I know you guys.
Oh, no, that's okay. So bit.ly, bit.ly .ws/C/Y B and numeral 4, and enter. This is a moment of truth. Like, please, make sure I gave you the right thing and make sure we.
Now, I teach middle school.
Mm-hmm.
So, and we do a little bit of coding of their one-to-ones that we have So they've got like Swift, and that's what I've taught intro to coding. But is with the sprites, is that still like, is it not too babyish for like 7th, 8th graders?
Let me talk to the group about that, because I'm gonna say no. That's a first activity that gives you the CS Discoveries course for game development, video game development.
Because I saw that on code.org about like developing apps and games.
Yeah, Game Lab is actually, Sprite Lab, what that activity is the first step to then Game Lab.
Okay.
Even your middle schoolers, unless all of your middle schoolers are coming from like a solid CS
Molly?
program,
Right.
I still would make that a first activity
Okay.
for your sanity.
Molly, can you read the Bitly address again?
Yeah, so the Bitly address is bit.ly, BITLY, .ws/CY_B4. Okay, I have that our 5 minutes is up. I had a great question for some of our secondary teachers that I wanted to address. So the question was, okay, Hello World activity seems cool, but is it too babyish, my words, not theirs, for secondary students? Here's my recommendation, or my comment. It depends on the CS background of your students. So if you are looking for middle school, high school coding curriculum, then code.org CS Discoveries is a great place to go. When I was teaching CS to middle schoolers, we would do the Game Lab unit for CS Discoveries, but really Game Lab is just a more complex version of this hour of code activity with Sprite Lab. It's still the same idea of getting the students to select images and learning how to code animation to those images. So if you know you have a lot of middle schoolers coming to you with little to no coding experience, I recommend do this hour of code activity first for your sanity before you try to dig deep into Game Lab, because I think they will appreciate having immediate success with Sprite Lab before you go deeper. Now, look at the activities, guys. We have everything from thinking about integrating things already planned to code, ELA, code a scene where the characters from the text share their viewpoints of different events. Any subject, code a digital newspaper. You literally could use an hour of code activity, or Google has a CS First activity on storytelling where they basically are making like a front page of a newspaper. They're adding pictures, they're adding their text, they're practicing their writing skills, they might be researching a topic. So tons of ways to integrate. So you know there are additional pages. So Daniel, can you press this right top arrow button that's beside it says 2/4? So up at the top. Yes, sir. So we have this, and then one more, and this one as well. So this was just a fun way to let you guys crowdsource some ideas. So we have this ideation activity. So when you go back into the classroom, hopefully this sparks some various ideas. Let's hop back to the slide deck, please. Now we're almost out of time, but before I wrap things up, did anyone have an additional question about CS integration? This is kind of a wild thing to do a session on in this amount of time, right? Because CS integration is going to be different based on your grade band and your subject, but at the end of the day, find things you already teach that you ask students to create work product for? And again, my favorite place to start, look for those posters, look for those slide presentations. They can still do a presentation. They're just going to code their work product instead of drawing it or instead of putting it on the slide. Okay, so in conclusion, I think this is an incredibly powerful thing because, guys, we know not 100% of our students are going to grow up to be professional computer programmers. But guess what? We don't need everyone to be computer programmers, but we need them to have the thought processes that come along with computer science and computational thinking. So we are cultivating this next generation of visionaries, programmers, inventors, engineers, and designers, because every child who comes through our classroom should feel like they have a place in the tech sector. So, okay. I think we're up. Here's my contact information. If you ever have questions, feel free to reach out. Thank you for spending your time with me. Enjoy the rest of your day.